Hello everyone, I hope you are doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is bus conductor, and it is an easy level problem. So I was not able to upload the video in the morning because I was busy with some work, and it is now that I've got some time. So before the discussion, if at the end of this video you find that this video is helpful for you, or if you were able to derive any value from this video, then do consider dropping a like on this video, and don't forget to leave out a comment any general thing you want to share or any other thing you wanted to share about this particular problem. That would be highly appreciated, because your engagement with this particular video will really help the YouTube algorithm to understand this video is actually helpful for you, and it will be able to reach more people like you who want to solve new problems. So let us quickly start with the problem. It says that there are some n chairs and n passengers, and we have been given these two arrays, chairs and passengers, where each of the elements denotes the position of the ith passenger or the ith chair, right? So we want all of the passengers to sit in one of the seats, and we want to find the minimum number of movements that we need to make. So we can make a passenger go from position x to x plus 1 in one move, and we can make a passenger go from x to x minus 1 in one move. So either it can go right or either it can go left, right? Now we have to find the minimum number of moves required so that all of the passengers have only one seat, right? So there will be n seats and n passengers, so it will be always possible for the passengers to have one seats of their own, right? So now let us have a look at the main logic of this problem. It's very straightforward. So you can visualize this particular thing as a number line. So let's say this is seat 1, this is seat 2. Obviously they will not be at equal distance. It can be at 1, it can be at 3, and it can be this is seat 1, this is seat 3, and it can be then at seat 7, let's say at position 7, and then we can have other seats at seat 8, right? So now let us assume that these are the seats in sorted order. Now what if there are some passengers, let's say P1, P2. I'm not numbering them. This is not representing their actual position on the number line, right? So if I sort all of them and just write P1, P2, P3, P4, these are all sorted values, right? Now if P1 is the smallest value, then among these 4 seats, it is always optimal to give the seat number 1 to person 1. Why? Because let's say P1 was present here, right? So the closest seat to P1 is S1. Even if P1 was present here, the closest seat to P1 might be S3, right? Let's say you gave seat S3 to P1, but the position of P2 will be greater than P1, right? So let's say P2 was somewhere here. Now this particular person has to move all the way to seat 1, right? If we don't do this, let us say that we gave the seat S7 to P2 and seat S8 to P3, right? So let's say now P4 is remaining, but now P4 will have to travel all the way back to seat 1, right? So this is a big problem. So instead of providing any other seat, it is always optimal. Let's say this is seat 1, seat 3, seat 7, seat 8. It is always optimal to provide the smallest seat or the seat with the smallest index or smallest position to the person with the smallest position, right? This way, what will happen is the value of P2 will be greater than or equals to P1, and it will be assigned to S3, right? So what we are doing is we are assigning the first seat to the first person and then cutting out the problem. For the remaining of the seats and the remaining of the passengers, again we do the same thing. We assign the smallest seat to the smallest person at the smallest position, right? We can keep on doing this. So basically we have to solve both of the vectors, and we have to add answer plus is equals to absolute value of, let's say this is chair of I minus passenger of I, right? Because the first person will be allotted the first seat and the second person will be allotted the second seat, and so on. I've already discussed why it is always optimal to do so, because let's say you assign some other seat to P1 and you assign some other seat to P2, P3 and so on, and there will be at least one position for which you will have to give the seat S1 to that particular person, right? In that case, you will have to move that person all the way back to this particular S1 position, right? So this is why it is always optimal to provide the smallest seat to the smallest passenger, right? So let us have a look at the code, although it's very simple. So what I've done is I've just sorted both of the vectors. I've initialized my answer with 0, and for all the values I've done a loop from 0 to less than n, and I've added absolute value of chairs of I minus passengers of I to my answer value, and I can just return this particular answer. So this would be the solution to today's problem of the day. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and let me just also show you by submitting this particular problem and its processing. Yeah, so you see it passes all the test cases and the solution is correct. So if you found this video helpful, do consider subscribing to this channel. It's always free of cost, and you can also unsubscribe later if you don't find the videos interesting. I see a lot of people who watch these videos regularly have not subscribed yet. So if you're one of them, then definitely consider subscribing. Share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.